Alright, so where do we end up? So we learned about arrays. Arrays are a way of like taking a bunch of data and shoving it all right next to each other in a contiguous way. You got indices. We learned what happens when you go to the end of an array or past the end of an array. You get undefined behavior. We don't like it. And so yeah, let's just remember all that. So arrays are things. They're a new idea that lets us hold a bunch of things of the same type. Does that work? There we go. So this is how you can make an array of ints, for example. Int r bracket equals whatever we want to put in it. 1, 2, 3. Okay. Curly braces. Let you put the stuff to begin with. And yeah, so this is what it looks like in memory, right? You got your r, and it has 3 ints inside of it. 1, 2, 3 at indices 0, 1, and 2. Yeah. So either implicitly or explicitly, every array has a size, right? This array has size 3. You can only hold 3 ints, no more, no less. And you kind of say that up front, one way or another. And you do not get to change that later. If you go to index 3 that just doesn't exist, that is bad. We don't want to do that, okay? So you can't change it later. That's too bad, right? And yeah, just like strings, you got those indices. And go to index 0, get the first int. Go to index 1, get the second int, and so on and so forth. And yeah, you use this kind of syntax, right? Go to r at index I and do something with it, right? Make it one more, maybe. Something like that. So you can use this syntax to both set and like get the current value for either eventual setting or printing. Okay? See out r of like j or something. Okay, so that's kind of arrays all over again. Let's go a bit deeper now. So let me talk about multi-dimensional arrays, because sometimes you don't want just like a long line of data. You want like a box of data, or a 3-dimensional cube of data, or even higher dimensional things. So you can have multi-dimensional arrays. A good example of that is like you want to store an image. Every image has it's a box of pixels, right? Some width and some height. And so like you need 2 indices. You need like a row index. Like I want to know about this color right here. What is it? So you're going to go to like row 2, column 1, something like that. And like maybe the color is somehow the number 42. I don't know. But to make a multi-dimensional array, you kind of need multiple indices. And so this is how you would like declare an array that is 2-dimensional. It's got 2 indices, all right? To make this one, for example, I'd make a 3x3 array of ints. Let's just pretend that every color is an int. More or less that's accurate. So I'd say this. Make an array, a 3x3 array of ints, and then set row 2, column 1 to 42. So you got 2 indices to work with, the first index and a second index, an x and a y kind of. So r to 1, set that please to 42. So that's kind of how that kind of works, okay? Once you make an array like this, maybe you've given a different number of first indices to second indices. Which indices are valid right now? This is going to make a 42 by 84 array. What are the indices you can use, is now the question. Well, you get R00, that's the start of it all, okay? And then the next one after that is R01, right? And this second index can go all the way up to 83, 0 to 83. So you can start like 0th row all the way to the 83rd column. That's along one axis, right? 83. And then you can use the other axis all the way to 41, right? 0 to 41 on the first thing. So 41. And then the very last index would be 4183, right? So you got a whole box of ints now. And then you could, of course, it's harder to draw, but you can make 3-dimensional, 4-dimensional, 5-dimensional arrays if you needed to. Okay, so let me show you that in code. I think I want to do that. Yeah, why not? So let's make an array that's multi-dimensional. All right, so let's just make a 3x4 array of ints. 3 things in the first index, 3 ints, and then 4 in the second, and I get 12 total, right? And so I can go to any index between 0, 0, and 2, 3, right? So I can go to like 2, 1, for example. Set it to 42. Just as usual, I just have 2 indices now. Set it, print it back out. There's no real difference. All right, just got multiple things, and that's useful for images and stuff like that. one day you'll need that knowledge, so we'll just get it right back out. Okay, so that's multi-dimensional arrays. Not too horrible, right? We're good with that? All right, so that's like something that arrays are great at doing. Yeah, let's keep on. Is that a question? Yeah. Just like you're making a normal array, you got to say what kind of thing's going inside at the deepest level. No, can't be mixed. Got to be only one. Bless you. So it could be double R, int R. Can't share. Can't share, unfortunately. So yeah, there are some issues with arrays. That's one technically. You can only hold one type of thing inside. You can kind of get around that once you learn more, but more or less that's a thing. Some other bad things are the size of your array is set in stone up front. You cannot change it later. If your size is 42, you just have to like use size 42 all over the place and never forget. All right. Also, your array has no clue how big it is, right? It doesn't even warn you like going past the end or anything. So your array doesn't remember how wide it is in general. So like you have to store that my size is 42 if you need that for later. Is that a question? Yeah. I can't hear you. No, yeah. You can't do that. You have to say you can only give the size that you want it to have up front. Like if you want size 5, you'll make a size 5 array and that's all you get. If you want room for later, make a like size 10 array or something and just leave room. It's like make it room and just like don't fill in these sides. Does that make sense? That's kind of your only solution there. Make a bigger array than you need up front and just like use the empty indices that you haven't used yet. Yeah, that's a great idea, right? Great question. So yeah, arrays don't know how big they are. They're stuck with however big they are. And because of all that, you can accidentally go past the end, and that's unfortunate. Okay? So your array has no clue how big it is, though you just set it somewhere, most likely, up front in the same function. So yeah, you can't pretend the existence. If you made a size 4 array, you can't pretend that it's really got a fifth thing in here at index 4. Okay? So these are a bunch of issues. These 3 issues, at least, we will solve with this other idea called vectors. Right? I told you this at the very start. Arrays and vectors are what these slides are about. Arrays are like the old thing. Vectors are like the cool new thing that solves a lot of these problems. Okay? At least these 3. Okay? There's other problems still. But before we get there, I would like to teach you about one concept that you're going to need to know. All right? It's a very, very common thing to have to do, and it's called swapping. All right? So let me show you how to swap 2 values in an array. Okay? So let's say I've got an array. It's holding like 1, 2, 3 at indices 0, 1, and 2. And let's say I want to take the 3 and the 1 and have them switch places. All right? That's what I'd like to do. So the obvious solution does not work. You'd be like, all right, I want to move the 3 to index 0. So the thing in index 0 becomes the thing at index 2. And then the thing at index 2 becomes the thing that at index 0. Swap them, right? This does not work. This is bad. Does anybody see why it's bad? Let me draw a picture as you're thinking about it, but see if you can beat me. 1, 2, 3. That is a 3. That's 0, 1, and 2. So this won't work, even though you kind of think it will. Well, 0 gets 2, 2 gets 0. Because watch. This first line, r of 0 equals r of 2, that's taking right. I'm going to set r of 0 to whatever is in r of 2. So that's going to become 3. Boop. And then, see what just happened? Then I'm going to set r of 2 to whatever's in r of 0. All right, 2 becomes whatever's here, which is still 3. I just lost that 1. That's a problem. So the way we fix it is to use a temporary variable to keep around that r of 0 that I'm about to change first. All right, so here's the secret. Here's what I want to do. 0, 1, 2, it held 1, 2, 3. What I'm going to do at the very start is I'm going to set a temporary variable, just an extra int somewhere, with this guy. All right, save the 1 there, because then, like, here's kind of the code. Int temp equals r of 0, let's say. And then I can do this game. I can do r of 0 equals r2. Okay, and that will set r of 0 to this, so it's going to hold 3. And I have not lost that 1 now. I can say, okay, r of 2, you're going to be the old thing, which I safely saved away in temp. Okay, so that's going to correctly swap it. So now bring the temp into index 2. So there it is. It's doing the right thing, and that's the secret. Okay, so that's what we want to memorize, this idea. Okay, questions about swapping, and obviously this works for any two indices. All right. One trick that I use to memorize kind of how this works is like you start off, of course, setting the temporary variable so that you don't lose anything. But look at how the thing on, it's always the thing on the right side of the assignment on the previous line becomes the next thing on the left side of the assignment on the following line. So those r's of 0s correspond, r's of 2s correspond, like the temps kind of wrap around. That's how I think about it almost. You can never do it wrong if you remember that. Okay, so that's how you swap things, and that will be a useful process for a lot of different reasons. All right, we'll get there one day. Let's see. Okay. If we're good, I think that is enough of arrays. Let's move on to something called vectors. That's a brand new type in C++. It's defined in a library, so we have to include the vector library. There's some page on that. So here's like the vector type. You can just search C++ vector, and it'll give you this. Like here's, just like strings, here's all the things you can do to a vector. It's fun, okay? Click on constructor, that's a fancy word. That will tell you kind of how vectors look. Here's how you declare a vector of ints, for example. And it's just doing some fancy stuff. So you can click on these, have fun, try it. But yeah, vectors are very similar to strings in that we're going to not use, we have the ability to go to indices, like go to index I. But we can't do it like that. That's not the syntax we're going to use for vectors. It's going to be just like strings, it's going to be .at I, okay? And that will be very, very useful for us, all right? So here's vectors. It's just fancier arrays that are better for us, at least, okay? So a vector is what's called a dynamic array, which is already better than a normal array. Dynamic just means move around, right? For us, it means it can grow. So a vector can grow in size. That's really nice. There's a pushback function that it can do, all right, that adds something at the end. It's like you're shoving it to the end of the vector, okay? So that's this one. Pushback, and click on it to see an example of it. Not very useful maybe, but it's like vector dot pushback, the thing you're gonna add. So for example, say you somehow made this vector. It looks the same, right? Let's say you've got your 1, 2, 3. So this is already solving a problem that arrays have. If you say v dot push back with an underscore in between, push back 4, what's going to happen is it will make a brand new index for you. Wherever it was at the end, it's going to add a new one, brand new index, and it's going to hold that value that it should hold. Right? So that's what pushback does. It adds a brand new element to the end of your current vector. All right, so let's remember that. Adds a new element to the end. Okay, so in addition, you can be like, I would like to go to index 4 or something and like mess up. Don't use that syntax. Use the same kind of string-like syntax. All right, so instead of this one doing this, you use .at. So v.at 4, and through the magic of vectors, if you do it like this, see how that's an index that doesn't exist right now? If you do it this way with .at, it will yell at you. It will give you a runtime error if you mess up, which is exactly what we want, okay? So that's beautiful. It doesn't just like silently agree and let it happen, okay? In addition, vectors know their own size. There's a .size function kind of operation, .size here, just like strings. Give me the size of that thing, and we'll print it out. So you can ask for this current vector v's .size, and it will just give you back how big it was, 4, which is nice. So yeah, let me show you a little about vectors. I guess the first example is there's a couple ways to make it hold 1, 2, 3. All right, let me show you how to make 1, 2, 3 in vector land in a couple different ways. All right. Is that a hint? Yeah. Is what? Yes, for vectors. That's right. So instead of this syntax, like that was for arrays, this one's for vectors and strings. Yeah. Okay, yeah. So 2 ways to make it hold 1, 2, 3. So it is its own library, just like strings. So if I want to use vectors, I have to include the vector library. And yeah, here's how you make a vector. So remember the old way. So this is like the array way. Int r bracket bracket equals 1, 2, 3. You can kind of do a similar thing with vectors. It looks like this. I would like a vector, and I'd like it to hold int. So I'm going to use the less than signs, like angle brackets. Vector of ints, please. And I like to call it v. Okay, that's the new type. It's always like, it's like a qualified type. I would like a vector of ints, please. I like a vector of strings, please. You put the type in there between less than and greater than signs. And then you can do this. So it's very similar to the array syntax, right? So that's one way to do it. And then let me just prove to you that it holds what it holds. Let's go to each index, v at 0, and then like let's do space separation, v at 1, v at 2, and then a new line. So that's one way to have it hold 1, 2, 3, just as we know how. Right? Very similar to arrays. Just a new way to access, right? So there's 1, 2, 3, of course. Another cool new way that you could set this vector to hold 1, 2, 3, let me make a brand new vector, is I can start it out empty because I can use this pushback thing. It doesn't make sense to ever have an empty array, but it totally makes sense to have an empty vector because it can grow. So I would like a vector that holds ints, please. I will call it something other than v because I already used v. I'll just say vector v2 semicolon. All right, so v2 is an empty vector at the start now. Of ints, though, hold ints, capable of holding some ints. And I can say v2.pushback, which adds to the end. Right? If there's nothing there, that is the only thing in there. So now it holds 1, now it holds, now it holds 1, 2, and now it holds 1, 2, 3. So I'm adding 1, then 2, then 3 to the end always. All right? And so just like this, I can print them out. Just gotta say v2. And that is another way to make vectors work out. All right? So you can fill it up as you get things, which is really cool, right? So yeah, those are your 2 options, more or less. Normal array-like syntax, or you can just add things one at a time, which is really cool. There is a way to start it off with a certain size full of garbage, but honestly, nobody really uses that. You can look it up if you'd like. All right. So that's that. Demo number 1. Demo number 2 is let's get a bunch of elements from a user and shove them all into a vector. And let's say I would like to get a bunch of numbers user as long as it's not -1. We'll use -1 as the special I'm done typing numbers now number. Okay, so we're going to get a bunch of ints from the user until they type -1. That'll just mean I'm done typing. So we could get 4, we could get 42 elements from the user. They'll just get as many as they want to type until they type -1 and put them all into a vector and do something with them. Okay, this is something you could not do with an array. You'd have to always hard code like a size, right? Get a maximum of 1,000 elements, no more, no less. But vectors can always grow. So that's great. Great for us. All right, so I'll make a new one, vector of ints v3. And yeah, just forever, while true, until I break out of this manually, I would like the user to enter a new number. Enter a number to add to v3, or -1 to quit. So they're incapable of adding -1, sadly. We've given up that number. But yeah, let's get a number from the user with cn, and then I'll put it, now it's n, right? I'll put it into v3 as long as it was a -1. So if n was equal to -1, that's indicating that the user's done typing now, so we should stop our loop. But otherwise, if we're still here, then we got a number that we want to put into v3, and so I'll say v3.pushback, add it to the end, whatever n was. See how that'll potentially add infinitely many elements until the user's done typing. And then once the loop is done, we can use whatever was in v3, whatever the user typed. So what's the best way of doing this? Yeah, so just like, yeah, just like for arrays, we can go and use a loop to iterate through this, right? We can go v at I all day long, and that'll look like this, okay? So here's how we can use our vector v3. We can say something like this: for int I equals 0, I is less than, v can know its size. That's great. So I is less than its size, kind of like we did for strings, I plus plus. So that's what we're going to do, all right? That's the first way. So let's see. So we filled up v3. Once the loop is done, it's full of stuff. We're ready. We want to iterate through v3 and visit every index. All right, so that'll just be what we do. So I'll say for int I equals 0, I is less than. I just want it to go from index 0 to the size minus 1, and oh man, does v3 know its size, whatever it was. Could be a million, and then I plus plus to advance it. And so I'll see out v3 at whatever I is, and I'll space separate them and break the loop only after it's done. All right, so here I am using v3. I filled it up, I made it, and started out empty. I kept adding to it until the user was done. I type -1 to mean they're done. I'm out of this loop now. And then I come to this loop to go through every valid index of v3, and it knows its size, and everything is wonderful in the world. All right, so let me compile and run, and hopefully see it work. So like I'll fill it up with 42, 43, 44, 45, and maybe now I'm done. So I'll type -1. And then that's the things that are in v3. Here they are, and I'm printing them back out. Okay, questions about that? Yeah. Oh, thank you. That will be easier to read now. Thanks. All right, so yeah, it's just however you can type as many things as you want, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you're done, though, you type -1, and that'll stop the loop. So v3 got whatever I put in it. It got whatever I put in it, and here are all the values. All right, that's very nice. That's very, very powerful. All right, so yeah, this will be a good program to study, I think. All right, let's see. Yeah, we go with that. Okay. So those were those two demos. Now there's a fancier way to iterate. We did this way already. This is like you can go and use the size and use indices. There is a fancy version of iteration that is available in the 2011 version of C++ and later, and obviously we're using that. We're using like, I think the 2017 is like the default standard right now. So we did this. It's called a range-based for loop. Okay, it only works for vectors. This way works kind of like arrays. Works for vectors and arrays almost. And this range-based for loop thing only works for vectors. Okay, so let's say I've got a vector v, and it holds my favorite numbers 1, 2, 3 at indices 0, 1, and 2. You can of course do this and like print them or something. Or this is what a range-based for loop looks like. You say 4, and then in between your parentheses, you're going to say the type of thing you're getting out. For every integer, that's kind of how you read it. For every integer, call it element in v. That's a colon right there. All right, you read it as in. For every element in v, call it elem. Do this with it. All right, you can hopefully you can kind of infer what's going to happen by me saying it like that. All right, so then I can use this elem variable thing. Cout elem. And like a space. Okay, so what happens in this range-based for loop? We kind of read it like this: for every int elem in v, do this with elem. What's going to happen is it's going to range through the vector, as you might expect, and it will set this variable called elem to each element. And you could have called it x or y or whatever, but I'm calling it elem. And elem will get a chance at being each element of v, and it'll just like run that loop as many times as there are things in v. So the first time you hit the body, elem will be set to 1, you'll print your 1, then it'll make sure the next time it's set to the next thing, so 2, then it'll make sure it's set to 3 the last time, and then it will make sure to stop the loop. It'll just go through all the things from left to right in the vector, call it a day, okay? So that is the secret, and this is just a variable name, could be anything, x, y, z. That's how it works. That's not bad, right? That's kind of helpful. Less thought, less typing even. So let me show that to you. Iteration. Did I spell that right? Iteration. That's easy. So, all right, if I want to use vectors, I need to include the vector library. And let's make a vector of doubles. Why not? Vector of doubles. Call it v. and it'll hold 1.5, 2.75, 3.14. All right, and finish it off there. So 2 ways to iterate through it. We've got for int I equals 0 using indices. I is less than v.size, go all the way up to, but not including it, strictly less than I++. C out v at I, and then like a space in between. We'll break the line after we're done with all of them. That's one way to do it, or we could do the range-based for loop, which is a mouthful, but it's less typing when you actually do it. So for every double, you gotta use the right type this time. So it's a vector doubles. For every double elem in V, what do I want to do with elem? I would like to, I don't know, I can just print them out, see out elem space, but you could of course do math, do whatever you want. So those are your 2 options. If you don't want to go from left to right, if you want to go in like reverse or something, this of course is not going to work for you. You have to do the indices stuff. But if you just want to go from left to right, visit everything, that is a kind of a quicker way, less thought. So this is going to do the same thing. Either one. You have options now. Right? Any questions about these magical things? Just figures it out. It's printing them out because I said C out. I could have like been calculating the sum or something. It didn't have to be printing. It's just like the body. This is kind of the equivalent. Okay. Yeah. Anybody else? So yeah, let's keep on showing cool stuff then. What next? What do I want to do next? All right. Here's one. Let's sort these guys. Let's sort our vectors and arrays. This is a common thing that you're going to want to do. Like I got a bunch of numbers from the user. I'd like to do something cool with them. Let's put them in order and then do that cool thing. Makes things easier for a lot of algorithms, right? So sort is actually a function that was given to us. We can use the sort function. It's in the algorithm library. Just kind of makes sense that it's there. I think that's in the other section. There it is, algorithm. And it's called sort. So I click on sort. Here's kind of how it works. It has some weird names, but I will tell you what they mean. Here's some normal examples down here. So if you have a vector, this is kind of how you sort that vector. You say it like this. Some words begin, some words end maybe. If you have an array, then where's that one? Oh no, they're just making a vector from the array, never mind. If you have an array, you do something completely different. So honestly, it's kind of hard to understand this, so I'm just going to give you an example and it will make sense, all right? So first of all, it takes 2 things. First of all, the sorting function, it takes 2 things. It gives you, like it takes a start and end or a first and last, however you want to call it. So it's called sort, and you're going to say sort, right? You're going to call your function sort, and you're going to give 2 things, right? And the 2 things that you will give are the beginning and ending locations of your vector / array in memory, right? Which I have not really taught you how to do that, so you're just going to have to take my word for it. If you have, like, this is kind of how you say it, like, something cool, it says, like, the starting location of my vector / array, comma, and then not exactly the ending location, not exactly the last index or something. You're going to give the memory location of 1 past the end, which is very weird to think about, I know, of your vector / array. All right, so that's kind of how you call sort, and here's just the secrets. Let me just show you how. It would take too long to teach you the other way, but it's sorting from start inclusive, if this makes more sense. It's sorting from start inclusive to end exclusive. And so if you want to actually sort the ending element, you need to go 1 after that. So it'll just get right up to the actual end and not including that 1 past the end weird thing, all right? So again, this does not matter to you right now. This is all you need to know. If you would like to sort a vector, here's what you do. You say sort, and the way to get the beginning place in memory for your vector, you just say v.begin. It knows where it begins. It's got its own little operation function that does that. If you want to know 1 past the end, where's that in memory? The vector also knows that. Just say v.end, it's good to go. All right, so that's how you call sort for vectors. If you have an array, you say this. You say sort the name of the array by itself, and then you say the name of the array plus the size of that array. Somehow this is the starting location in memory, and somehow this is 1 past the end of that array in memory. I can explain not during class if you'd like to know more about that. Eventually I will teach us though. It's weird, but now you know if you want to. You have the ability. So let me show those two to you. So yeah, just for now, just come back to the slides, copy it off. This is one of those few times where we don't have the tools to explain it just yet. So I want to sort some vectors and arrays, and I want to use the sorting function, so I'll use the algorithm library. So that's for the sort function, right? And so let me make an array and a vector. So, and it's got to be jumbled, obviously, so my favorite jumbled vector and array. So there's that one. And let's do the same for vectors. We'll be like, I would like a vector events, call it v, holds the same value. So I like to sort these. Obviously, they're not in sorted order right now. So here's how you do it. You'll say sort, and for the array, you say its name, and then you say array's name plus its size, and it's plus 7, because it's size 7 array. So that's for the array sorting. So now it's sorted somehow, magically. And then for the vector, you say sort v.begin, and then v.end. Those two calls, right? And that will correctly sort both of those guys, and we can prove that. For int I equals 0, I is less than 7, I plus plus. Deal with the array. And then do the same thing for the vector. We can use the range-based for loop for the vector, can't we? Hoo-hoo. So we'll say for every int e in v, let's call it. Shorthand. See out e, and then a space, and then a new line. All right. So there's the code. I guess I'll have to zoom out a little bit so you can see all of it. That's more or less what's going to happen. So let's compile and run. And I should see 2 lines of sorted numbers, and there they are. Cool. Yeah. Where? Oh yeah, so you're confusing indices right now with size. So the size is how many actual elements are there in this array. So there are 7 total. Yeah, so it's are you talking about this call right here? Or this right here? Which one? Okay, yeah, so this is, well, we want to go only up to 6. This is strictly less than 7, so that's correct still. And then this is, it's just all, like, you just have to say r plus its size. I haven't told you why yet, but that's why. Okay. And then we have sorted order, yay. You're good with that? You will need this one day. Very useful. All right, the last thing that I want to do today, we're not going to code it up. We'll code it up next time, but we're going to discover an algorithm together, all right? So I want to give you some time to brainstorm. You have some ideas, hopefully brewing in your mind right now. You know about arrays and vectors now. Let's pretend we have a vector, or an array, honestly, of some size. It's like, I don't know, we've got this vector v, it's maybe size 4 or something. Let me move it over. So here's a question that I want to pose to you all. And you'll work together on this. So like, here's your vector. 1, doesn't have to be in order. 1, 4, 3, 2. These are its things, all right? I would like you to get into little groups, peer instruction groups, talk to each other, and then brainstorm. You don't have to write it down anywhere, but brainstorm, think out loud, draw pictures, show to each other, an algorithm to reverse that vector. So v looks like this right now. By the time it's done with your algorithm, v should look like this. See if you can come up with a reversal algorithm. It's got to be, what, 2, 3, 4, 1, right? At indices 0, 1, 2, and 3. How could you do it? Think about it, all right? And so you don't have to write code, just like talk about it like in English, bullet points, like what do we need to do? How can we make this reversed? Though, keep in mind that your code needs to work for any size vector, not just the size 4 vector. It should also work for a size 104 vector. It should reverse everything, all right? So you'll have to use its size somehow, not just like hard code. Okay, it goes up to 4 or something. Okay, but that is that's what I want to leave you with right now. So take several minutes to discuss with your people sitting next to you. Say hello, and then we'll come back and see what we're thinking. All right. So try to come up with a reversal algorithm. What will and do attendance too. I'll stop attendance after we're done with this if I can remember. Now is a good time to think about this. Another minute or so, our conversations seem to be dying down. Did we get it? We have our answer. If you're brave, I would like to hear it from you in just a second. Alright, I think that's enough time. Let me do my administrative tasks first. Stop that. And then, before I ask a brave soul, I should mention about the midterm. If any of you, I have not received any DSPNS letters from any of you in this class. So we're all going to be taking this test in the classroom, and we all get 90 minutes right now. If any of you have like an accommodation or extra time on the test, one, I need a letter from DSPNS. You need to do that very quickly. And also you're going to need to schedule that test at the testing center. Okay, so if that applies to any of you, please do that like today. All right, because otherwise you have to take it and you only get 90 minutes. You deserve your extra time if you can get it in. Okay, so just remember that. Disabled students programs and services, something like that. Yeah. So what was I going to say? Oh yeah, any brave souls would like to explain their ideas that they came up with. How would you reverse your vector? Yeah. Nice. Hmm. Very good. Nice. Good. Yeah. Did you guys come up with that yourself? Really? Or did you cheat and read ahead on these slides? Awesome. That's really good that you noticed all that. Was there another hand up? There's other ways to do it. Did somebody come up with a different way? How about this way? Make a brand new vector, call it V2, iterate through this in reverse order, start at index 3, go down to index 0, push back to that second vector, suddenly it's reversed, and then just like shove whatever was at that other vector into the old one. That's one way to do it. But yeah, we're going to do the fancier way. We're going to learn the way to do it in place, all right? And that's going to require us to do the following, all right? This is going to be the way that I teach you how to do it. All right, if it was 1, 4, 3, 2, kind of here's the idea. We would like to swap this guy and this guy. Nice, nice, nice. And this guy and this guy. Yeah, it's like there's a mirror here. We want to swap along the mirror on the middle line. And so the 2 and the 1 get swapped. We know how to do that. And then the 3 and the 4 get swapped. That is the correct way to do it. Yes? And then, though, we do have to worry about if there is something actually in the middle. Okay? So let's say we have an odd size vector. 8, 6, 7, 5, 3, or a ring. I would like to reverse this, so I need to swap this guy and this guy, right? This guy and this guy, and then, like, do I swap this guy with itself? I just don't want to do anything once I hit there, so we're going to have to watch out for that, okay? So that's the secret, and we'll have to turn it into, what is it? In place, without an extra vector or anything. 3, 5, 7, 6, 8. Okay? So that's what we're going to do. We're going to do that swapping. That's going to be the algorithm that I teach you. It's more complicated than making the second vector and just iterating in reverse and pushing back. Right? Try it that way, though. That's the way that I know you could do right now. So here is the secret. We're going to come up with the algorithm right now, but I'm not going to implement it. My request is to try to implement it before I do next time. But here's how it will work. What needs to happen right now is our question. Let's say we got a vector v, and we have these values. 1, 2, 3, 4. So I want to swap, right? Let's start thinking about this concretely. I want to swap index 0 and 3. I want to swap index 1 and 2. Indices 1 and 2. All right? So that's what I need to do for that vector. If I had some other vector, v2, that was a different size, what do I need to do for it? Let's just write down all the things. If it was instead like 1, 2, 3, 4, 5, doesn't have to be in order. We just want to swap it 1, 2, 3, 4. Those are my indices, and that one is not very centered there. What do we want to do? We would like to swap this guy with this guy, this guy with this guy. I guess we could technically swap this guy with itself. That would still work, but that's just wasted effort. Okay, so let's just not do that. All right. So now our question is, for our algorithms, there'll be a loop. What do we need to swap? Right? Which indices are we swapping right now? We need to swap. We need to swap. All right. Which indices first? It's always like 0 and 3, 0 and 4, right? How can I get those indices? It's always, right, swap index 0. And then how do I fill in this blank? How do I always know the ending index? Size, not quite size though. This would be 4, this would be 5. What else do I need to do? That's right, v.size is included in this. It's a -1, right? That'll give me index 4, that'll give me index 3 here, and that will always work. All right, so that's the first time I swap. And then I think you can imagine what's going to have to happen here. I want to swap next index 1 and then the second to last one, right? 1 and the second to last one. It's always getting smaller on each edge, right? Or moving that one over and moving that one over, yeah? So it's going to be swap indices 1 and v.size -2. Yeah? Let's move it over. Do you see how if you just repeated that, you did it the right number of times, it would all work out? Does that make sense? So now, the question is, how many swaps do I need to do? All right? So let's figure this out together. It's like, how many rounds of this do I need to do? ... So let's say we had 1, 2, 3, 4, 0, 1, 2, 3. We have the idea now. So, okay. Let's play it out, all right? If if you thought that we need to do, okay, we got 4 elements, we should do this, we should repeat this 4 times, right? That would be, okay, we're going to swap 0 in size minus 1, 1 in size minus 2, 2 in size minus 3. I guess let me write it out correctly. V dot size minus 3, and then indices 3 and V dot size minus 4. That would be a good idea, right? It's got 4 elements, got to do that 4 times. Let's see what happens. So, all right, swap indices 0 and V dot size minus 1, so that's 0, and in this case 3. So swap 4 and 1. 2. Swap 1 in size minus 2, so that's 1, and then 4 minus 2 is 2. So swap those guys. I got my 3 and my 2, all right? And it's actually sorted right now, but if we kept going, watch what would happen. 2 in size minus 3, so that's going to be this index, and size minus 3, so 4 minus 3 is 1. It'll swap them right back, actually. 2 and 3. And then 3 in size minus 4, so that's indices 3, and then 4 minus 4 is 0, so 3 and 0. It would swap them right back and be in the original order again. Isn't that funny? So we wanted to just stop there for that size. Okay, that was half. Does that make sense? So we wanted to do 2 swaps for this one, all right? And then for this one, we also want to do 2 swaps again, don't we? Because we don't care about this middle element. Just swap this guy with this guy, that's 1 swap. 1 round of this idea. And then swap this guy and this guy, that's another swap. And then skip the 3rd one. So we still need 2 swaps for there and for there. How do we get it? Like, how do we go from 4 to 2? Because that's our size. How do we go from 5 to 2? It is going to involve division. Good. So notice how. It's the last key idea. Notice how. It's just like I want to swap for half the elements, essentially. So for an even array, that makes complete sense. 4 over 2, I want to do 2 swaps. 2 iterations of this game here, okay? 2 swaps. For this one, though, I still want to do 2 swaps, even if it's odd. So what's 5 over 2? That's 2.5, right? But I want 2 out of this. Is there a way, is there a type of division that will give me just 2? There is. Good, yeah. So I can do integer division, and that will give me how many swaps I need to do, even on an odd-sized array. Because I just don't care about the middle. I don't want to swap it with itself. 2 swaps. And that, if you do enough examples, you will convince yourself that that is the right amount. Right? So I want to play this game, swap this index and that index, and then move them inwards, swap that index and that index. I want to play that game size over 2 times. Right? So it's always odd or even, size over 2 swaps. That is the secret, and that is an algorithm. Do you think you could implement that? You need to start like some iteration variables, keep them working, know how many times you're doing these things. But that's the answer. It will work. So your job is to try this. That would be a great exercise to see if you are comfortable with vectors / arrays and looping and like following these instructions. This is like a great way to study, honestly. Great way to get better at programming. But yeah, if you can't get it working, don't worry, because I'll do it for us next time. But that's the last thing I want to say for the lecture today. Are there any questions about that or anything else? All right, so that's where I want to stop. We're still not done with arrays and vectors. It's a complicated topic. There's a lot to learn. But that's where I want to stop for the day. Don't forget about your midterm, of course. And yeah, no new lab, because like your other lab was due way after the midterm. So that's all that I want to record as well.